Good morning. My name is Aryan Singh Rana. In today's video, I'll be explaining you the solution to the LeetCode number 7 with the title Reverse Integer. It is a medium difficulty level question and says that given a 32-bit signed integer x, return x with its digits reversed. If reversing x causing the value to go outside the signed 32-bit integer range, which is from minus 3 raised to the power 31 till 2 raised to the power 31 minus 1, then return 0. Assume the environment doesn't allow you to store 64-bit integers, signed or unsigned. Okay, so it is a pretty simple question, but it has given us some constraints. Now, what is happening over here? It is that we have been given int data type number, and we know that the data type int can hold till only 32-bit integer value only. So what it is saying that we need to reverse the integer order of the digits within that integer and return that integer. Now, if while reversing the integer, if it exceeds the 32-bit range inside the which is given for the int data type, then we need to return 0, and the 32-bit range should not exceed minus 2 raised to the power 31 till 2 raised to the power 31 minus 1 range. So it is a simple question, and you can see that in the example number one, you can see that the x is 123, or you can say 123, but the output is 321. So you can see that the order of the digits within the integer has been reversed. Now coming to the example number two over here, as you can see that the integer, the input was minus 123, but the output here is changed and the reverse digit would look like minus 321. Now, in the example number three, as you can see that it is 120, but when we reverse the placements of the integer in placement of the digits inside the integer, the output would be 0 to 1, but 0 is insignificant if it doesn't have any integer value before it, or then it is considered 0, and we do not need to print it. That's why the output is 21 over here. Now coming to the code is pretty simple. Now, as you can see that the very first step is very crucial over here. I created a integer, so I created a long data type variable with final num as its name and initialized it with 0. Now, why did I use long over here? I used long over here because long data type has the capacity to store 64-bit integer. And we also need to check whether our answer when reversed does not exceed the 32-bit integer. So for us to check it, we need something to hold a number which can be greater than 32-bit integer. That's why I created a final variable with data type long, because it can easily store a variable, a number, or a number which exceeds the 32-bit range. As you can see, as I told you, I have initialized it as 0. After that, I created a while loop which would check if x is not equal to 0. This condition is crucial for the while loop to keep running. Now, why I did it is that because we will be taking out the each and every integer or digit in some behind the each and every integer and adding it to the final num. So if the x reaches 0, then it would simply terminate the whole while loop. Now, as you can see that I initiated another int data type variable, which is large digit, which would store the remainder of the division of x divided by 10. So, and after that, the division, it would store inside or update the final num, which would look like final num is equal to final num into 10. So first, this calculation would be done because according to BODMAS rule, it would first multiply 10 to the final num, then it would add the remainder or that is stored inside the last digit to the final num. After that, we simply update the x variable with the quotient of the division of x itself divided by 10. Now, I'll show you how this calculation is working. For example, we have been given a number 1. Let's take the example as well only. Now, what the last digit would store is the division or the remainder. This percentage sign represents the division between, sorry, the remainder coming out of from the division between x and 10. So, if we divide 123 with 10, the remainder would be 3. So the last digit is storing this integer, which is 3. After that, as we can see that the final array, the final, I am representing it with final. The final first stored 0. Just a second. The final first stored 0. After that, the calculation was that final should be multiplied by 10. Then I would add the remainder that I got from the integer division to the final num. Now, so if we multiply 0 with 10, then nothing's happened because 10 0 if 0 is the multiple of with anything, the only answer you would get is 0. And after that, we added the last digit. And so now what would our answer become? The final would become as 3. As you can see that the last digit is stored 3, so it would become 3. Now, we are doing, we are updating this value with the quotient of the division, with the quotient that we will get from the division of x and 10. So the division of x and 10 give, so x would become the quotient of division of by division of x by 10 would become would be the 12 as the quotient. So now x is 12. Again, the last digit, now the while loop will check if it is 0. So as you can see that x is not 0. So again it would reinitiate the while loop, and it would again do the same steps again and again. So now the last digit will store the remainder from the division of x and 10. So now 12 divided by 10 would give us 2, and the now final num would be updated like how it would now, as we know, the final num uh so just a second. As we know that the final num is currently storing 3, so according to formula, first we will multiply final with 10, so it would become 30, and then we would add the last digit to it. So after adding last digit to it, what would happen? Now the final num would become, just a second. Now final num would become 32, because 30 plus 2 is 32. And as you can see that, you can already picture that the reversal of the digits between the integer has been started. Reversal of the digits of the integer has started, and this same process will keep on going till x reaches 0. And after that, we get the final num, which contains the reversed digits that was originally which reversed digits of the integer x. Now, after the while loop has been terminated, it would go to the final if else check. It would first check if the value of the final num exceeds or precedes the integer's maximum range and the minimum range respectively. So that's why I'm using this if command over here, which would check if final num is greater than integer dot max value. Now, integer dot max value is represents the maximum value a integer can hold, which is a maximum 32-bit value that the integer can hold, or means if either of the condition is true, then the if command would initiate, or if the command inside the conditional statement if would trigger if either of these two condition is true. Now, the second check is that if the final num is less than the integer's minimum value, integer dot min value, it represents the minimum value the integer can hold. So if the final num is like I said, if final num is exceeding the integer's max value, or if it is less than the integer's minimum value, then we would simply return 0 as been told by the question itself. After that, we know that the number reversal of the digits has been taken place, but we do not have not taken account the its nature, if it is positive or negative, because as you can see that in the second example, we have simply reversed the digit, but we have not taken account the sign that it currently holds. So because we need to return the output in the negative only, as you can see that the input was negatives and output is as well is also negative. So to retain its nature, the number's nature, we will check if x is greater than 0. If x is greater than 0, then what would happen is that this it would return int. Now this bracket converts the whole number which is currently in the long data type, it would convert it into the integer data type, and it would multiply final num with -1 to retain its nature. As you can see, as we know that if we multiply any number with -1, it would convert that number into negative. If the number was already negative, then it would become positive. That was just the basic maths concept. Now, as I told you, if the number is negative, if x was is negative, then it would convert it into the negative integer. by multiplying -1 with the final num. And this, as I'm repeating again, this int within the parenthesis would convert the whatever the result after the multiplication into the integer data type. Again, if this command is not triggered, it means that the x was greater than 0, or the x nature of x is positive. So the final return statement simply returns the positive integer type value. As you can see that again, I'm using the int data type within the parenthesis before the variable name, which would convert the whatever value inside the variable into data type. And that's how the code would be running. Now I'm simply checking all the test cases. As you can see that my code has successfully given the right answers for all the test cases. Now I'm submitting the code. As you can see, my code has been successfully submitted, and my code beats 90.23% of the rest of the users who submitted the solution for the same code, so for the same problem in Java. Now coming to the time complexity of this whole code, the time complexity is mainly dependent on the number of iterations done by the while loop, and the number of iterations done by the while loop is totally dependent on the number of digits inside the integer or the input integer we have been provided with. So the time complexity of this whole loop would be O of n, and represents the number of digits inside the integer. Well, that's all for the this question in LeetCode. Thank you for watching.